We're now in our last section, so we are going to kind of review the graphical transformations. So if you recall from last year, the very general graph transformation has 3 letters, A, H, and K. This year, we're going to add a new letter. That letter is C, and that has to do with something else. But anyways, let's look at it. So it always starts with A. And then the next thing is always that function. Whatever that function is, the parent function. And then it always comes with x next. The new thing this year is this thing called c, which is going to be the denominator of x. And then we have a minus h plus k. And do you remember what hk refers to? Yes, the vertex. Okay, let's recall what these things mean. What does H do? Left and right, good. Okay, what does K do? Up and down. And then what does A do? Stretch and compress, but this year, because we introduced C, we're going to be very specific. It's vertical, stretch, and compress. Vertical, so it has to be up this direction, vertically, okay? Because C has to do with horizontal. Stretch and compress. And we haven't talked about the reflections yet, but that is going to come in as well. Okay, so A and C. A is vertical, C is horizontal, okay? All right, so now let's kind of write down the notes, same thing as last year. So when K is greater than 0, which direction do we move? Mark. When K is greater than 0. Okay, up. And then when K is less than 0, it's going to go down. When you see x minus h, Caleb, do you know? X minus h, which direction?
To the right?
Yes. When you see a minus, you're actually going to go to the right. When it's x plus h, you're going to go to the left. Vertical stretch and compress, we said, has to do with A. So it's actually the absolute value of A because we don't care about the actual sign. The number itself, the value is more important. So when it's greater than 1, is it vertical stretch or compress? Somebody? Stretch, yes. So vertical stretch. And when that number is between 0 and 1, it's going to compress. Okay, horizontal stretch and compress is the same. It's actually going to be C. And then if that number is bigger than 1, it's going to be horizontal stretch. When that number is in between 0 and 1, it's going to be compress. Horizontal compress. The last thing is reflection. X and y-axis, and this year there's a new one called origin. So origin, remember, means we're going to flip it 180. Okay, x-axis is the negative inside or outside? Do you still remember? Is the negative inside the function or outside the function? Outside, yes. So y-axis, where is the negative? Inside, yes. Origin means the negative is outside and inside. Okay, now let's do some examples. Before we do that, we have to know where we're actually moving, like what is being transformed, or where is the starting point of all your transformation. So for example, if you have a y equals x function, the point that you're actually moving is this part. So that's basically you're moving the h and k part of every function. Okay, and if you have something that has a very distinct vertex, you move the vertex, obviously. If you have something that has an endpoint like this one, you move the endpoint. Something like this, you move kind of the vertex part or like the dip part. And same thing as this. This is the cube root x part. You move that center part. So just so that you're aware of how we're moving these. Let's start with very easy ones. Y equals x minus 3 squared. Okay, identify the transformation and then graph the transformation. Well, before you identify, you have to figure out which part is the parent function. What is the parent function on this one? X squared, yes, y equals x squared. So then this minus 3 does what? Huh? Right 3, yeah, right 3. Okay, so that is a parabola where we moved right 3. So easy stuff. Next one, absolute value negative x. What is the parent function? Absolute value x. What is the transformation? Reflect what? Ooh, so close. The negative is inside or outside? Inside, so y-axis. So basically you take this v and then reflect it over the y-axis. It's going to be exactly the same. Okay, so these are just single transformation. I only made one change to the parent function. Now we are going to do parent functions. Multiple transformations. So the key parts about multiple transformation is you want to start at the parent function and you want to apply the transformation until the function looks exactly like what you want, the desired function. Okay, so the part that's the hardest one is when you're applying something inside the function, like you're going inside f of x and you're trying to put a 3 on multiply 3 to x. That is a very strange thing. You have to put a parentheses around it, and it gets a little crazy, so we'll kind of do that together. But before then, let's kind of talk about reflecting. Okay, just a review really quick. Across the x-axis, is the negative inside or outside? Outside. Across the y-axis? Inside. Across the origin? Yeah, inside and outside. All right, so we're going to take the function 4x squared minus 1. We're going to reflect it across the x-axis, across the y-axis, and across the origin. When we take that function and reflect it across the x-axis, where is the negative?
Outside.
Outside. So what we're going to do is take the negative and then put it outside of the function. The function means the entire function. Okay, so this is going to be negative 4x squared plus 1. If you're not sure if this is really going to work, you can try and put it on decimals. So basically, you take the original function and then the final function and see if this function actually reflects over the x-axis, which it will. All right. Across the y-axis, where is the negative? Inside. Inside the function, which part is my function? X squared. So it's going to be 4 times negative x squared minus 1. Across the y-axis is put the negative inside the function. The question you have to ask yourself is, which part is the function? The function is x squared. So this is going to be 4x squared minus 1, which means that this graph is actually exactly the same. All right, across the origin, where's the negative? Outside and inside. So negative 4 times negative x squared minus 1. Okay, so this is negative 4x squared plus 1, which is the same as across the x-axis. All right, let's have you guys try one. Across the x-axis, across the y-axis, across the origin. Okay, Sally, do you have across the x-axis?
2 absolute x minus 4.
Yes. Allison, do you have across the y-axis? Absolute value and then x minus 4? You forgot to put the negative somewhere for across the y-axis. Across the y-axis, where does the negative go? Inside or outside? Inside. So you have to put it inside, which is here. Okay, last one. Across the origin. Trey, do you have this one? Yes. Okay, now let's look at transformations. It gets pretty tricky as it goes, so please stay with me. Okay, general transformation. Because it is very tricky, you want to remember you always want to factor out horizontal stretch and compress because it's going to change where your HK is, so it's really tricky. Okay, let's start with easy one though. Negative x plus 4 squared plus 3. First, identify the parent function. What is the parent function? X squared, very good. All right, what's the transformation? Up 3? Everyone always wants to do the up one. This is easy. Left what? Left 4, and then reflect what? X-axis. Okay, so in the past, I always tell you order matters. That's because we do this by order. But I realized that it's very confusing to just go in order. So I realized it's much faster if you just think about where the HK is. So where is HK? Negative 4, 3. So, bless you. So we want to just go to negative 4, 3. And then draw the parabola. There's a negative, that means it reflected over the x-axis, so then just have it point down. This would be the fastest way. Instead of taking the original parabola, move left, up 3. Now, do I reflect it down, or should I have reflected first before I move it up? It's very confusing. Just stay with the HK first, and then the reflections come later. Okay, next. Oof. This is a little tricky. All right, now there's a problem because usually we don't see a number or anything next to x, but this time there is a negative next to x. Actually, this is not even in the usual order we see, right? Usually we see x first. So now there's a negative, that means there's going to be a reflection over the y-axis, but what we said before was always factor out whatever is next to x. So we actually want to factor out this. And you can see that now my vertex changed. The HK was not exactly what I thought it was before. So you have to make sure you factor out the negative or whatever number there might be next to x. So now, where is HK? Where is the parent function actually? X cubed. Okay, so then where's HK? 4, 0. Okay, if you didn't factor it out, you would not have seen 4, 0. You would have moved left. If you graphed it, you'll realize your graph is actually on the right. So it made no sense. Please be careful. This one, what's the transformation? 4 to which direction? Right? Okay, right, 4, and then what? Huh? Ooh, wrong axis. Y-axis. The negative is inside the cube, right? The negative is inside the cube, so it's going to be y-axis. Okay, now we get to the hard ones. Okay, is there something next to x that I have to factor out? Yes. Can you guys see it? No? You're like, I did not think that was a thing. That's a 1/2, right? Because I can write x over 2 as 1/2 times x. So that 1/2 shouldn't be there. I have to take it out of everything inside that function. So this is going to be 1/2 times x. And then what? Minus what? Minus 8. Okay, if you can't see that, basically you're dividing everything by 1/2. Okay, so whatever you factor out is essentially taking the term and dividing that number out. So 4 divided by 1/2 is going to give you 8. Okay, before you graph, what is HK? A0. So you see, if you didn't factor out that 1/2, you would have started graphing at 4, and then if you use your graphing calculator, you'll be like, wait a minute, my vertex should have been at A0. How come I didn't see it when I was looking at the equation? So please be careful. Okay, now tell me the transformation. Huh? Sorry, I heard something. Right, what? 8, good. Right, 8. That's 1/2. This is the tricky part. I can actually write this like x minus 8 over 2. Right? 1/2 times that is the same thing as divided by 2. Okay, now this 2, is it A, H, K, or C? C. C is a new one, right? We said, so C is the number itself, not 1/2. It's whatever is in the denominator. So is C going to be, in this case, C equals 2. Is it going to be a stretch or a compress? Stretch. Stretch, because that number is bigger than 1. Okay, so it's horizontal. Stretch by 2. Okay, horizontal stretch by 2. And 2 more things. We have a 3 and a negative outside. What do those 2 things do? Yeah, vertical stretch 3. Okay, good. Reflect x-axis. Okay, so let's talk about this horizontal thing a little bit because it confuses people all the time. So let me give you a few more examples. Let's make sure everybody copy everything down first. Okay, so let's say that you have a function that looks like x over 3 squared. Is it a horizontal stretch or compress? Stretch, but I have only 1% answer, so I'm not sure if everybody else get it. So it is a horizontal stretch. Do you guys know why? Because C is what? 3, right? Okay, now let's look at another one. Okay, is it horizontal stretch or compress? Compress, why? Yeah, the number is 0.5 or 1/2. Okay, now let's do the hard one. Horizontal stretch or compress? Compress. It is compress. You have to change that number into a denominator. Okay, so it is not a denominator right now. You have to put this 4 in the denominator. How do you do that? I try different things every year, and the fastest way I can think of to do this is just make it a reciprocal. So that becomes 1/4. So if you put it in the denominator, it's the reciprocal. So if you don't see a denominator, take that coefficient and then make it reciprocal and then put it in the denominator. Okay, let's try another one. Stretch or compress? Take that number, find the reciprocal. Okay, how many people say stretch? How many people say compress? Okay, stretch. Because the number is 2/3. When you make a reciprocal, it's 3/2. So actually 3/2 is in the denominator. Good? Okay. One more for feeling better about this. I'm running out of tricks though. Oof, I'm really running out of tricks. That's just strange. Okay, stretch or compress. Raise your hand if you think it's stretch. Raise your hand if you think it's compress. Okay. Same amount of people as before. Okay, it is compressed. What is that number in the denominator? Well, yeah, 1/12. Okay. All right. We are ready to move on. Let's see if you guys can get this one. I think pretty much we learned everything. Let's start. Amelia, give me one transformation. Okay, good. Davies gave me another one.
Stretch 3.
Yes, vertical stretch 3. Junior, give me another one.
Down 7.
McKenna, give me the last one.
Reflect y-axis.
Good. Okay, if you were to graph this, you would start with HK, which is 2, -7. This is a square root graph, so 2, -7. Start here. Stretch 3, and then reflect y-axis is actually going to be this way. So something like that. Kind of like that. Usually it goes this way to the right. Reflect over. Okay, now you're going to be given a parent function and some transformations. You have to write the function. Okay. 6 units to the left, reflect the y-axis, vertical compressed by 1/3. You're writing the equation, yes. Try it. When you have a y-axis reflection, it's very tricky with your left and right movement. It's going to be y equals 1/3 times -x minus 6 squared. Okay, if you put +6, please be careful, because remember we said you had to factor out that negative. If you did, you'll see that this actually will help you move left. If you left it as a plus, it will actually move right. So please be careful. Okay, start with the function square root x. Shrink horizontally by a factor of 1/3. Shift right 6. Oof, this sounds horrible. Okay, try it. Shrink is the same as compress. Okay, so you are moving right 6. So no matter what, you're gonna have to do this. And then you're gonna shrink horizontally by a factor of 1/3. So that's gonna be like that. So if you kind of clean this up, you're gonna have a 3 times x minus 6, which is square root of 3x minus 18. A lot of you wrote something like, I don't know what you wrote, but it was still correct. Okay. So this is correct. I think some of you wrote something different, but it's not correct. I'll tell you when I see it. But when you have something like shifting right and left with a horizontal, then you have to be careful because it has to apply to everything. All right, that's it for today.